Have you ever just stopped to think about how your data actually gets to you? I mean, it's not magic, right? It's this massive, totally hidden infrastructure of cables and waves. So today, we're pulling back the curtain on these physical highways of data and digging into exactly how information gets from there to here.
I mean, think about it right now. As you're watching this, little bits of data are flying from a server somewhere, maybe halfway across the globe, and they're reassembling on your screen in real time. How does that even work? What is the physical stuff that's carrying all that information? Well, that's the big question we're tackling today.
And the answer, the secret sauce, is something called transmission media. It's just a fancy term for the actual physical path that connects a sender to a receiver. You can think of it like the plumbing of the internet, the actual pipes, the cables, and the invisible airwaves that make our entire digital world even possible.
Now, this data highway really only has two main lanes, two completely different ways of getting information from point A to point B, and we call them guided and unguided media.
So guided media is pretty much what it sounds like. The signal is guided or contained inside a physical path, like a wire or a cable. It's a nice, neat, closed system. Unguided media? That's the total opposite. It's wireless. The signal is just broadcast out into the air as electromagnetic energy, free to travel through space with nothing solid to guide it.
So let's start by taking a tour of that first lane, the physical, wired world of guided media. We're going to look at the three main types of cables that really form the backbone of almost all of our networks.
First up, we've got the humble twisted pair cable. Now, if you look closely here, you can see it's two insulated copper wires. But they're not just next to each other, they're twisted together. And that twist, it's a brilliantly simple, low-tech way to cancel out electrical noise from things like power lines, which keeps the signal nice and clear.
You've definitely seen these around. This is the classic cable used for landline phones and for hooking up computers in an office or at home. It's the reliable old workhorse that really got our connected world off the ground.
Okay, next up is coaxial cable, or as most people call it, coax. The whole design here is about one thing, protection. As you can see in this diagram, you've got that central copper wire carrying the signal, but then it's wrapped in all these layers: insulation, a shield, and a tough outer jacket. Every single layer is there to protect the data from outside interference. And all that protection means it can carry much higher frequency signals than twisted pair can. And that jump in capability is what made it perfect for cable television and later on for the high-speed cable internet that a lot of us still use today.
And now, we get to the true marvel of modern networking, fiber optics. This is a whole different ballgame. Instead of sending electricity down a copper wire, we are sending pulses of light down a strand of glass that's literally thinner than a human hair. The diagram here shows it perfectly. The light just bounces off the walls of the glass core, traveling for miles and miles at unbelievable speed.
And just how fast are we talking about? Well, data rates on a single fiber have been shown to go over 200 gigabits per second. To give you some perspective, you could download a full-length, high-def movie in less than a second. It's just a staggering amount of information being moved by a tiny beam of light.
And that incredible speed, that massive bandwidth, is exactly why fiber optic cables are the true backbone of the modern internet. These are the giant data pipes connecting continents under the oceans, powering our entire high-speed world. And hey, as a bonus, they're also lighter and more durable than the old copper stuff.
Okay, so we've toured the physical highways. Now it's time to switch lanes and explore the incredible, invisible world of unguided media, where data is literally flying through the air all around us.
First up, radio waves. Now, these are a type of electromagnetic wave that is just fantastic for broadcasting. Just like the towers you see here, transmitters can send signals out in every direction at once, covering a huge area. Think of it like ripples spreading out on a pond.
The really amazing thing about radio waves is their ability to travel really far and even punch right through walls. This makes them perfect for AM and FM radio, for broadcast TV, and of course, for the Wi-Fi that is probably connecting you to this very explainer right now. The fact that they're omnidirectional is their greatest strength. One transmitter can serve tons and tons of receivers all at once.
Next, we have microwaves, and these are a whole different beast. Unlike radio waves that just spread out everywhere, microwaves travel in a very straight, highly focused line. You can think of it like a laser beam of data. And that means they need a clear line of sight between the transmitter and the receiver, which is why we use those big parabolic dishes to aim them so precisely.
And this point-to-point, focused communication is absolutely essential for our modern wireless world. Think about it. That precision is what allows our cell phone networks to work, beaming signals between towers. It's what powers satellite TV and GPS. It's even used for high-speed networks that connect buildings across the city.
And finally, let's talk about infrared. I guarantee you use this every single day. The perfect example? Your TV remote control. This is one of the simplest forms of unguided media out there. It just sends a direct, invisible beam of light from a transmitter to a receiver.
Infrared is incredibly cheap and simple to build into devices, which is why it's in everything. And you know its biggest limitation? The fact that it can't go through walls? That's actually a feature. It's what ensures that your remote doesn't accidentally change the channel on your neighbor's TV.
So, we've seen the wired world and the wireless world. We've looked at cables made of copper and glass, and we've explored waves traveling invisibly through the air. Now, let's put it all together and see the complete picture.
This table just lays it all out, doesn't it? You've got your workhorse twisted pair for phone lines, your heavy-duty coax for cable, then there's the lightning-fast fiber for the internet's backbone, and on the wireless side you have the wide reach of radio for Wi-Fi, the focused beam of microwaves for satellites, and the simple convenience of infrared for your remote. Each one has its own specific job to do.
And that really brings us to the most important takeaway of all this. It is not about which one of these is best. They're not competitors, they're all building blocks, and they work together in this incredibly complex, invisible dance. A signal might cross the ocean on a fiber optic cable, get beamed to a cell tower using microwaves, and then finally arrive at your phone as a Wi-Fi radio signal. They're all essential pieces of the puzzle.
And that leaves us with a really fascinating question to think about. As our hunger for data just continues to explode, is our future going to be built on even faster fiber optic cables buried in the ground, or on smarter and smarter wireless networks that fill the air around us? The answer is probably both, working together to build a future we can't even imagine yet.